Hello, everybody, and welcome to JavaScript Jabber. I am your co-host, Joe Eames, and my other co-host is AJ O'Neal.
Yo, 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 it's Solder.js coming at you live from the office room with all the electronics everywhere.
Do you have a lot of electronics everywhere?
Yeah, it looks ridiculous. It looks like I know way more than I do. If you just look at my desk right now, you'd be like, wow, that dude's a maker. Well, that dude went through retail therapy is what happened.
Retail therapy, right.
This episode is brought to you by Triplebyte. Applying to programming jobs sucks. You have to put the right keywords in your resume, you spend hours and hours on the phone screens and take-home projects, and that's assuming the company even responds to your application. Well, if you're a software engineer, Triplebyte can help. They work with over 400 top tech companies, from big names like Dropbox and Adobe to exciting startups. You do one brief online interview with them, and if you do well, you go straight to final interviews with the company on their platform. It's like the common app for software developers. Triplebyte does not look at your resume or where you went to school. All they care about is if you can code. I've helped dozens of software developers with various credentials get jobs, and this looks like a terrific way for you to get in and get interviewed and get a job without a lot of the hassle and overhead. You can go check them out at triplebyte.com/JSJabber. That's triplebyte.com, byte as in 8 bits. As a special offer for listeners of this show, if you take a job through Triplebyte, they'll offer you a $1,000 signing bonus.
There's only 2 of us today, so I don't think a host makes any sense. We're co-hosts now, AJ.
All right, that's cool. That's
Cool.
It's very benevolent of you.
It is benevolent. Oh, yeah. Well, I don't think so, but whatever. Okay. We are going to be talking about TypeScript. Is it good or bad? Which is a perfect episode for AJ and I to talk about because we're both strongly opinionated. We love to yell and shout things out, regardless of how much we know about them.
That's true. That's true. I think I'm going to be especially good at this because I don't know that much about TypeScript. That makes me more capable of having a strong opinion of it.
Right. Yeah, so let's get the ball rolling. Let's talk. I think it'd be good to talk background and frame our experiences with TypeScript itself and then with typed languages as well, you know. So you want to go first on that?
Okay. So first of all, for those that have been living under a rock, TypeScript is a typed version of JavaScript that compiles back down to JavaScript. You want me to talk about my experience with typed languages, my programming path, or
yeah,
okay.
Give us a brief rundown of that and any relevant experience with TypeScript itself.
Well, I could tell you my first experience with a typed language was I copied and pasted an element of an array in C to be able to get a scanner driver working.
Was that effective?
It was actually. Like, I got it wrong the first time, but then I messaged the guy and he's like, oh, you need to increase the size of the array because the arrays are statically sized. And I'm like, oh, okay. And I did that. And then I got my scanner working, so I was pretty happy. So type languages for the win, except that if it had been dynamic, I would have just been able to add the thing to the array and I wouldn't have had to change the size of it. Well, and that's not true either because there's plenty of languages like Rust and Go where you just declare it and the compiler can be like, oh, look, there are statically 8 items in this array. Therefore, I will type the array as the type of things that are in it, and I will make its size fixed to the size that it is. So,
right.
So I started out with, like most people do, I picked up, first like BASIC, but then after that PHP, and then Python, then Ruby. So mostly dynamic. Had a little bit of exposure to C just as part of getting that scanner driver working. And then did end up doing quite a bit of C work at my first job out of college. But I'd already been familiarized with JavaScript at that time. Then the next 2 big things that in school I used Java, of course. Like everybody has to write Java in school. But I don't even count that as experience really because it was completely pedagogical and I didn't ever use Java in the real world other than, I don't know, like tiny little things. Then Go and Rust are typed languages that I really, really enjoy. I think they're both great languages, and but I had some exposure to TypeScript and I didn't like it.
Gotcha. Okay. So would you consider yourself to be more of a typed language person or a dynamic language person?
I don't think that's the right question to ask me because I'm both.
You're both? Ambityped.
Yeah, I'm ambidextrous.
Are you loosely typed?
Let's see. I forget that. Okay, so this is something we should probably actually bring up and get definitions for, because there's loosely typed, strongly typed, weakly typed, and strictly typed. Like there are 4 different types of types. I'm going to Google that. See if I
Well,
can-
dynamic. You missed dynamic. Right? There's
Okay.
there's a whole lot in there, and I don't think I have enough clarity to give a lecture on the various typings. I looked up a couple things as we were preparing for this. I see static versus dynamic, strong versus weak, but then there's still loose.
I think weak is loose.
Weak is loose. Okay.
So I think this is what it is. So static typing, I believe, is when it has to be determined at compile time, whereas dynamic typing types can change at runtime. And I think strong versus weak typing, I think strong typing is when you cannot change something. So you declare, var I equals 0. You cannot then later on do I equals the string foo. Once you declare it as 1, I think that you can't then redeclare it as another without it being a new variable.
Mm-hmm.
And then the weak typing, I think, is where you get things like implicit conversion. So like 0 equals quotes 0. That type of thing. I think that's what weak typing is.
Say that again.
So when you have the number 0 equals the string 0, and that returns true, you have weak typing because you're saying, well, these types can be coerced; they're similar. So I think when you can have a function or a variable that could store 2 different types that operate similarly, like strings of numbers and numbers, I think that's what weak typing is largely considered. So I'm a fan of strong typing. And I say strong dynamic is what I like the most.
Strong dynamic.
Yeah. Which I guess here's where my hypocrisy comes out. I think that would technically be TypeScript.
Interesting.
I think it's more, there's certain things for certain tasks, right? Like,
right.
If you just want to like loop over some CRUD quickly, I love JavaScript for that. I love the looseness and the flexibility and just like not having to be concerned about anything and just throw some data together, loop over it, munge it, throw it out. It's just awesome for quick scripting, prototyping, anything where you just want to get to the demonstrable results. But I also love Go very much, which is it has more of the strong typing. It feels dynamic. It is static. It happens at compile time, but it feels dynamic in that you don't have to declare that something's an int or that something's a string or whatever. You just do the assignment and it knows what it is, and it just has to be consistent, and the compile time checker checks that. But I find that to be really productive, especially if you're doing something like a parser or an API or things where you need it to be more stringent and you want it to go into production and be performant and you want to get faster failures. I think that those are the benefits I see. So I like both for different reasons. How about you, Joe?
Well, one thing I wanted to jump in here with is, as I was reading up a little bit about this, I saw something I thought was pretty interesting in this document. It says C is notoriously weakly typed because any pointer type is convertible to any other pointer type simply by casting. That was something I was not aware of. I myself don't have really much of a C background, but I thought that was pretty interesting. I feel like I have certainly some confusion on static versus dynamic. Makes some sense to me, right? It's compile time, right? A variable at compile time, you decide that it is a static type. You statically decide that this variable is a string and it's never going to be anything else but a string. Whereas the strong versus weak, I don't feel like I have nearly as much clarity about that. So
I feel the same, but I typically think of it as strong types are ones that don't coerce easily.
mm-hmm.
I would consider casting. Casting's an explicit thing. However, like for example, in Go or Rust, you can't cast a value to a type that it isn't without using what's called the unsafe packages. I don't remember if they're called the same in both languages, but a lot of the newer languages have a package or an import that's unsafe. And basically, when you import that, what it does is say, for this block of code that's within this realm of unsafeness, I'm not actually going to check your pointers. That's essentially what it does. But with the newer typed languages, typically you can't cast something to a type that it isn't, that's not allowed. I would consider that more of a language bug than really a type.
Yeah, this document mentions bugs in Pascal, like oversights in the design and stuff that introduce loopholes in the type system to make Pascal technically weak, even though it was designed to be strong. So, but casting, right? I think it's important to clarify casting is like an implicit type of a thing, right? Whether it could be implicit or explicit.
Oh, yeah,
right?
okay. I think of casting as explicit.
Okay. But there is implicit casting too, right?
There is, like what we're talking about, the string 0 and the number 0.
Right. Another example of that is when you concatenate a string with a number, right? Then it implicitly converts but that's different than converting types, right? So if I have a number, just about any language, so far as I know, allows me to create the string representation of that number through some piece of functionality, usually like some helper function, right?
Usually called string or toString.
Right. Usually called string or toString. So yeah, let me go through my like background and my experience with TypeScript. I've got a fair amount of experience with TypeScript. I've been doing quite a bit of it for quite a while, when TypeScript even first came out. But my background was I started in a language called FoxPro, which was, I think, dynamically typed, but probably weakly typed. I'm not 100% sure on that. And it's been so darn long. That was like 96 through 99, I think. Then I did a little tiny bit of Visual Basic, and then it was all C# from that point, which C# is statically typed, but you might call it weakly typed because you can, I think it's more strongly typed, but again, I'm not 100% positive on that. I did that for quite a while. I did that through pretty much the entire decade from 2000 to 2009, 2010. And then around 2010, I switched and started doing JavaScript. So JavaScript was my first exposure to a real, truly dynamically typed language. Other than, I think, around 08 or 09, I took a hand at trying some Ruby. And I discovered a ton of really interesting things when I tried Ruby that I thought, man, that's really cool. But it wasn't really until I started doing JavaScript and really got into the depths of it that I started to get this appreciation for the coolness of a dynamically typed language. And it was funny because I have all my C# friends who are very much into C#, but potentially was the only language that they knew or outside of what they learned in college, right? And so an only production language, they've been doing it for a long time. They knew it really well. They liked it really well. And I was talking about JavaScript with them, and they were like, oh, JavaScript, it was, and in 2009, JavaScript was a very different language than it is today. It was still full of, we'd been using it obviously for quite a while because we were building websites. But, most people, when you do websites in the 2000s, really your JavaScript was jQuery. And so JavaScript was this ugly language, and you use jQuery to hide the ugliness of it.
So, okay, interjection.
Objection, Your Honor.
As a computer science purist, I'm not going to change the world. I realize that, this is a problem. I have to deal with it. But I hate it when people refer to the DOM as JavaScript, because jQuery is JavaScript. The DOM is not. The DOM is like, some of it, depending on the browser, was either Java or C# or C++. The DOM is not JavaScript.
That is a very good point. That is an absolutely good point. And so definitely some of what I said was more about what the experience was like as a JavaScript. As a JavaScript programmer at that time, you weren't a JavaScript programmer, you were a jQuery programmer.
Well, yeah, that's kind of what I was getting to, is that people talk about the early days of JavaScript. What they mean is they were getting a browser to do stuff. They weren't programming. They were not being software engineers in JavaScript. Not to say that no one was, but like a lot of the stuff that was happening in JavaScript was code monkeying around. It wasn't.
Right.
It wasn't like building libraries and
logic, and it was widgets. A lot of it was widget work.
Yeah, like JavaScript in that time was starting to become, from this ugly thing that you had to use, it was beginning to transform into something that was eloquent. Right.
So around that time, I started doing some JavaScript, and I started telling my friends about the beauty of JavaScript. Some of them couldn't really get it, and I compared it. I was like, let's say C#, and I'm a big fan of C# even to this day, even though I haven't done it in forever. but I was a really big fan of C#. And I said, C# is like a wonderful 7 Series BMW. You got air conditioning, and it's got this nice smooth ride, and you can't hear the road outside, and it's just a fantastic experience, right? And everything about it is crafted to make it amazing. Whereas JavaScript is a motorcycle, right? And so when people say, well, how can you use JavaScript? It doesn't have this thing. You say, well, that's like asking, how can you ride a motorcycle? It doesn't have air conditioning, right? And it doesn't have a radio. Well, if you've ever ridden a motorcycle, you don't, although there are some motorcycles with radios, and they're even
very loud ones.
Very loud. Yes.
When they have radios, you know.
Right. So anyway, it's like in some cases the question, once you realize what it's like to program in a dynamic language like that and start experiencing, some of the questions just don't even really make sense anymore that people ask. And so I really went through this like revolution where I started doing JavaScript, and I was just so in love with it. And then, of course, I went through the CoffeeScript phase. I didn't actually do it, but did you do CoffeeScript?
I don't know, maybe for 10 minutes.
Yeah, that was...
I didn't... The thing that got me was... back then, the debugging tools have gotten so much better, but back then, you didn't have maps. And so people would get errors in their CoffeeScript, and Ruby syntax is different from JavaScript syntax, and particularly some of the ways that the like ternary operators and the like chained if else type operators would work a little bit differently. And so people would get these errors in their CoffeeScript, and they'd have a really hard time debugging them. One, because it's literally a different language. Like the semantics of the language work differently. And then you couldn't figure out, okay, how did CoffeeScript on line 52 produce error in JavaScript on line 78?
Right.
So I think I took a look at it, and it was neat because I just come from Ruby when I started getting heavily involved in JavaScript. And so it was neat, but it just, to me, it wasn't worth it. It was too distant from the real language. And I just didn't see the value in, it's like, if you're going to invest your time in what you need to learn.
Right. So CoffeeScript we should have like given an explanation here. CoffeeScript was a relatively short-lived phase where somebody produced another language that transpiled down to JavaScript, but they tried to kind of smooth out the rough edges of JavaScript.
CoffeeScript seemed huge to me. Like people were doing PRs where they'd rewrite an entire project in CoffeeScript.
In CoffeeScript, yeah. And certainly there's plenty of relatively well-used open source projects today that are still written in CoffeeScript.
Yeah, and it wasn't just small changes to the language. They were literally, it was Ruby. Like they were implementing Ruby in JavaScript as much as they could, as to every letter that was possible. That's what I remember of it, at least.
Right.
It was like hardcore Ruby.
Right. So then along the path comes TypeScript, right? And Microsoft came out with it. It was created by the language designer C#, I believe, right? Anders Heilberg is his name. I'm probably butchering it. He created the TypeScript, which was, they took, the same concept of CoffeeScript, another language that then just transpiles or compiles, however you want, whatever word you want to use, down to just regular old JavaScript to do things. And they took a slightly different approach, and it's a superset. So any valid JavaScript is valid TypeScript. Obviously, the converse is not true. And its number one goal is to add types, but it also does the several secondary tasks. It adds new functionalities, and one of the other big things that it adds in addition to types is basically the latest JavaScript transpilation. So you can use the latest JavaScript features and have browser compatibility. So if you want to use something that's really recent like map, and it's going to, or arrow functions, and it's going to a browser that doesn't support arrow functions, like an older version of, like a version of IE or something, then it will just transpile it out to regular functions. But so that's TypeScript. And when I encountered TypeScript, it was pretty interesting because I'd gone through this phase where I was loving dynamic typing and JavaScript, and then I encountered TypeScript, and the types started coming back, and I was a big fan of C#, still am, and I didn't dislike static typing or statically typed languages. So when it came back, it also felt very familiar as well to me. So I think that made it easy for me to relatively adopt TypeScript. So that's my background and experience with static languages and TypeScript. So moving on to phase 2 of our talk, TypeScript. And the whole point of this episode is TypeScript, good or bad?
So I'm going to start off by taking the pansy stance of, I can't say that it's either good or bad. I don't prefer it.
Why don't you prefer it?
There's a number of reasons. One is that I actually like JavaScript, and it seems like a zero-sum game with the alternate script languages. And like if one of them wins, JavaScript has to fail. It's not entirely like that, but it feels like that in the community. Like people are trying to get rid of JavaScript and they're trying to figure out what language to replace it with. But I actually really like JavaScript. And TypeScript is not necessarily, like it's mostly like JavaScript, but there are things that are different. And there are things that I find to be useful for writing concise code. Although like I don't disagree that you can get better out-of-box tooling with something like TypeScript. All that tooling, as far as I'm aware, is available in JavaScript as well. You just put annotations, you use JSDoc, and then you can get all of the type helpers in your tooling, if I'm not mistaken. But, you know, it's JSDoc. It's not the syntax of the language, and so it is a little bit more effort to write JSDoc than it is to just annotate the type right in the language. But right. So I mentioned earlier, I don't know if we'd actually started the show yet, but variable shadowing. I find it very useful, and maybe you can tell me, maybe the TypeScript does allow this, but I find it very useful to be able to do something like, I don't like to do it all the time. I don't like to overuse it, but it is useful sometimes to be like var num equals, you know, grab user input. And so now I have a string because user input was a string. And then I can do num equals parse int, whatever, you know, num. And now it's what it really needs to be. So I don't have to have like a num string or num input and then num. I can just reuse the same variable as I'm progressing to basically describe the same thing, but like in different process of what's actually happening with the parsing, so that it's, you know, continuous. And then just some of the dynamic, I'm going to say hacky-do, although I don't think it's like ninja foo hacky-do, but just, you know, some of the little hacky-do things you can do with a dynamic language where you just shove things together can produce more concise code where, you know, you have an object that's just a bag, meaning it holding different types of things, an object that has some numbers and some strings and some other stuff on it, or an array. Occasionally it's useful to have an array that has different types. Oh, well, one thing that comes to mind is a parser. If you're writing a parser, typically you're going to be dealing with an array of arrays. And it's actually kind of nice to be like, well, the first element in my array is going to be the number that signifies the type code of this thing. And then the second element of my array is going to be either a string or another array. Like it's nice to be able to munge things like that in some particular circumstances that I find myself in often. And so I like the looseness of JavaScript for those tasks.
Gotcha.
Especially when considering that it has to go into a browser, that all those bytes have to be shipped to a user. I know not many people care about byte size anymore, but to me, it's still important that you can have a smaller file that you deliver. And so I think it's probably not the real benefit that anybody should focus on, but I think that it is a nice benefit that you can have very small and concise code when the language is dynamic.
Gotcha. Right. So to clarify in there, are you talking about TypeScript bloating the delivery package size?
So I think that, yeah, you definitely are getting, from what I've seen, it definitely looks like you're getting a much larger deliverable because you're not taking advantage. In places where you could be taking advantage of things being dynamic, you're having more boilerplate. Like when I write Go code, there's a lot of boilerplate because of the type system.
Interesting.
Rust handles that a little bit better because it has a really, really, really clean macro system. But it is very typical in a type language. You get a ton of boilerplate, even if it's a really nice one like Go or Rust.
Right. I'm going to say I don't have much clarity in the fact or in any studies showing, and when I say studies, even informal, showing what delivery size of the transpiled JavaScript looks like comparison to how you would write it yourself, especially on something of any reasonable size. My gut tells me that there's probably not much difference in the delivery size in TypeScript because everything that it adds tends to go away during the transpilation process. So right off the bat, if I wouldn't necessarily assume that TypeScript actually creates a larger delivery size, although since there is transpilation going on in the process. But I assume even if you're not going to be using TypeScript, AJ, you're probably a fan of using Babel or something, so you can use ES 2018 features and you should put them down to 20 ES5 or something.
So there's a fair point too, because I don't use that. Like I just use vanilla JavaScript because it has everything that I need. Like I said, I liked JavaScript back when it was just JavaScript. So the language features that I would consider to be idiomatic suit me well enough. A lot of the new stuff that's syntax sugar that's been added on top, I find to be distracting, more difficult to visually parse, and I don't feel like it like, to me, I don't see a lot of value in it. So I'm not already using something like Babel. If I was already using something like Babel, then I probably would be less opposed to TypeScript, because I've seen the type of code that gets generated from these code generators, and I know it gets better, and I'm not up to the state of the art, so it's probably way better than I think that it is. But the code often looks like absolute crap and is really bloated because it's trying to emulate things in weird ways. The canonical example that I don't think has to be used much anymore was let. Used to have a ton of boilerplate for every let statement where you're doing all these try catches and basically just abusing try catches in order to emulate what a let looks like. So on every line that there's a let, you have like 3 or 4 lines of try catch boilerplate. Mm-hmm. So I don't think that's the case anymore, but there's a lot of stuff like that where I'm sure there's options. You could be like, compile -- don't actually check types at runtime or something, so that it doesn't put all of that boilerplate in there. But in output that I've seen, typically there's a ton of extra boilerplate and garbage that is difficult to reason about as a human, as well as just doesn't look like it would reasonably perform performantly and looks like it's increasing the code size. So not being a person that uses Babel, I don't know if I'm the right person to comment on the average person that does use Babel, what benefit or detriment they'd get with those sorts of things. In TypeScript, it probably all washes out, like you said.
Right. Again, I don't have much clarity, certainly on the current state. Anything, and as you said, things change so often, and we're talking about something like TypeScript. That's a language with, I'm sure, a relatively large team of people who spend a fair amount of time doing things like, hey, how can we make this code faster? And then there's the converse side to that, right? Where they might be able to write more performant and even smaller code than you would write using the same structures in ES5 that are written in TypeScript. There's also that possibility as well, because they have the opportunity there to do things that you either do not know about or don't have time to do, and the transpiler does them for you. So there is that converse side of it as well.
That is something that is totally valid and worth mentioning, because one benefit that you get with transpilers is if you write idiomatically according to the language that you're transpiling from, you can get major benefits from that, where it is better, more concise, and more performant than the code that you would have written by hand, because they are doing static analysis of the code and reducing easy to detect patterns into a much simpler end product. So I could be completely wrong with the current state of the art. It could be that your TypeScript code gets compiled even smaller and simpler than code that you would write by hand.
Right. I want to ask a related question to this. You said you're not a fan of, like, you have the idiomatic JavaScript. So let's say something like on the array, the for each function. Don't use it, map, etc.
Anything that is polyfillable, I think, is great, because it doesn't destroy the language. It gives you additional functionality. It's something that's standardized. Like I lament that Lodash is still a thing, because it makes me sad when people don't know that we already have trim and map and reduce and for each and sum, and basically, we don't have pluck and we don't have merge. But then I also would question, how often are you using that type of thing, and do you really actually need it. I think that this is what I see it as. When somebody adds something to the language that reduces the number of dependencies that are necessary in order to operate within the language successfully, I think that that's a win. So the polyfills, I think, or the polyfillable additions, I think, are great because they reduce the dependencies necessary to write normal code.
Interesting.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
I myself am a pretty big fan of TypeScript. I like TypeScript quite a bit. It would be my default for doing JavaScript. Even in small cases when I can use TypeScript, I would use TypeScript.
Tell me why, Joe. Tell me why. What is it that you love about it?
I think it comes down to a very philosophical view that I have about code. So in the early to mid 2000s, I got very much into the idea of code craftsmanship. And let me caveat that by saying I don't think that I'm a particularly great code craftsman, right? I've seen some amazingly written code, and I think in many cases, the difference between amazing code and moderate or average code is really just in the magical nuance that some people have, their superpower of naming variables and functions. That old adage that the two hardest things in programming are cache invalidation and naming, I find to be very true. Like, great names can really make a program. But obviously, there's so many other factors that make a program maintainable. The size of algorithms and, solid principles and patterns and all this stuff. So I got very much into this and testing and test-driven development and pairing and the gang of four patterns and all this very much stuff. And I, through that phase of my career, I adopted this view very much that the number one problem with computer science is the computer scientists. And maybe a more accurate way to say that
Dagger
is
to the heart.
Yeah, the problem with programming is programmers, right? That's 99% of all the problems. It's not the languages and the constructs and any of this stuff that we constantly debate over, like whether or not TypeScript is good. It's the people problem, because no matter how amazing or terrible a language is, the programmer can either do so much to smooth out those edges with what they write, or can completely destroy it with what they write. No language, right, forces you to write maintainable code, and vice versa. No terrible language can not be improved by a really good craftsman or engineer who knows about writing good code. So I very much have this view that it's much more important to worry about the human factor of code and writing readable, maintainable code, that I very much am not against making slower code, bigger code, more bloated code, just so long as the code stays maintainable. Because as long as the code is maintainable, you can then begin to address your performance issues of all kinds. Performance is not just how long does this algorithm, does it take 1 microsecond or 2 microseconds for each loop. It's also, or what is the O factor, the big O notation of this code, but also like package delivery size and latency and all these other factors and security and all these things. Those can all be addressed so long as the code is maintainable, right? So long as people can go on and maintain the code. But I've been at too many places where there was that really, really, really core piece to the application that was a 2,000-line file that everybody was afraid to touch. Even the original writer of the code, who's there 3 years later, is afraid to touch that code. And if you can't touch that code, then you can't fix problems like performance. And what's a performance problem today is not a performance problem tomorrow. And things that people say, well, this is so much slower. In many cases, it actually doesn't even matter.
I absolutely agree with you. I think that whenever the conversation of speed comes up, it needs to be dropped, and it needs to be later evaluated. Is this important? Because 90% of the time, it isn't. But sometimes it is.
Right. I've heard some statistics about either 4% or 8% or something like that of your code actually contains performance problems. So if you prematurely optimize, you have a 92% chance of working on code that does not have a performance problem. So as an example, I recently sent out an email to the massive newsletter list at Thinkster. I send out like 3 emails a week. And one of them was about the for each loop on arrays. And I talked about it, and I contrasted the for loop to the for each function, I guess not construct, but I contrasted them. I showed the for loop, and then I showed the for each is a analogous, for the same construct, and did that several times, and taught that is, and then I even taught what they were and how they worked, and how to use them, and how to use all the various aspects of the for each function. And the only people that replied to me, there's like 5 people that replied to that email, and every one of them pointed out, said things like for is slower. You didn't say that. You didn't say that for was slower. I don't use for each, or sorry, for each is slower. I don't use for each because it's slower. It was some variation on, hey, it's slower. Did you not know that it was slower? And one person,
because when you've got 7 items in your list, you want it to be blazing fast, because those extra nanoseconds, the users notice and they won't come back.
Right. So one person even went so far as to just simply reply with no text. It was just a screenshot of a performance measurement in the Chrome developer tools, right? Of the 2 constructs, showing that for was for each is 3 times slower, for was 3 times faster. So in each case is I can't even think of the last time I was iterating over an array that was so large that the speed of the loop actually mattered. I probably have at some point in my career, but I just can't remember. Every time I'm looping over arrays, I'm looping over a few dozen, a few to maybe most 100 elements. Maybe, I've almost rarely gone above that.
I've mentioned this example several times over the show because it's the only example I've ever encountered in my entire career in JavaScript where it mattered.
Mm-hmm.
And I don't think that it matters anymore. I haven't gone back and retested the old code to see, but from what I understand, the performance improvements, it's been 100x improvement, so it's negligible now. But I was iterating over pixels of an image that was something like 80 million pixels. No, it wasn't that much. It was, I don't know, but it was millions of pixels.
Mm-hmm.
And that was the only time that it's ever mattered in terms of measurable performance difference. So, and today we have better tools in the browser with Canvas and, whatever, the kind of stuff I was doing, you don't even need to do anymore. So I really can't imagine that on the web or even in Node, I can't imagine that someone would run into a case where a for versus a for each has any performance difference, or even the performance difference they expect, because the way that they're optimized under the hood, you can get better performance. If I'm not mistaken, you can get better performance in some cases with a for each than a for.
Interesting. Yeah, I even went so far as to write a follow-up email about, the premature optimization, and I even put in this demo in StackBlitz that iterated 10,000 times over a loop, and I put 2 buttons, and one of them used for the loop and one of them used for each, and I actually challenged people, click the buttons and it'll show you the output, and please tell me which one is the for loop and which one's for each. That was 10,000 items.
Yeah, you wouldn't even be able to measure that in milliseconds.
Right. So anyway, it's a long story coming back to the idea that
what's the point, Joe? Get to the point.
Yeah, that was a really long...
Code craftsmanship. Some code craftsmanship, for each loops, now back to TypeScript.
Blah, blah. And then coming back around to that, things that help the human factors, I'm willing to sacrifice a lot. So if the code is bloated, which again in TypeScript, I don't think we could say that because we don't necessarily know that it is. But whatever the drawbacks of TypeScript, if it produces more easily maintainable code, then I'm a fan of it. And I wouldn't necessarily call it incontrovertible evidence, but there is a preponderance of evidence of even academic studies that show that typed languages produce fewer bugs. Now, it's still relatively hot. It's certainly hotly debated, although it's mostly hotly debated by people who are not performing studies or reading peer-reviewed studies. Not that I actually read any of the peer-reviewed studies, but I did read about them. So I am a fan of having types for that reason. the fact that it's likely to produce fewer bugs. I do feel like TypeScript produces more readable code because between the annotations and the IntelliSense in there, it makes it easier to write code. But yet I still get to like feel very fluid with JavaScript, although I will admit that I relatively frequently butt up against the type system and have to like, crap, how can I can't, and sometimes they're just really frustrating. This type is giving me the compiler is warning me about the type that I can't course this, and the error message is so complex that even with a relatively large amount of TypeScript experience, I can't parse through it enough to actually fix what the problem is with casting. And then I use those tricks of like just casting everything in order to try to address the issue. So I do admit that it does sometimes bite me in the butt, the type system, but I do overall like TypeScript and feel like it's a good thing in that it improves code quality. And so, yeah, that's kind of my spiel on TypeScript, that it's a good thing and that it should be used. And let me put it, so I'm going to throw back something at you, AJ. Ryan Dahl, the creator of Node, just a month ago, launched or announced his new project, Deno, which I was trying to figure out what the heck Deno was, and I realized Nodedeno, right? It's just Node slightly transposed. So he announced Deno, and Deno is a Node alternative, also written on the V8 engine, but he wrote it in TypeScript. And
in Rust, by the way.
Yes, and in Rust, that's right. He did write it also in Rust. So I think that's pretty interesting. I do see a fair number of large projects. Now, I think that's probably pretty poor evidence to say, well, hey, so-and-so who's smart is doing this thing, so therefore this thing is smart. That's probably a really poor argument to make. But I do think it's interesting to see that a lot of people I admire and who I think are really smart scientists who have come up with amazing things are saying, hey, we're doing this and this and that. Is that the Stack Overflow survey came up with Rust as the number one most liked language by people who use it, right? I don't know how much that has to do with its types, but anyway, I do think there's this correlation.
A strange community. Not strange isn't bad, but it is
peculiar.
It's an interesting. Those people. I go to the meetups, and I don't know that I can quite call myself a crustacean because I don't. The way they speak, I don't know how to explain it. It's almost like a cult that you just become part of when you start speaking as if you're part of it. So like I like it, but I'm not like ready to be like we. Like everybody that uses Rust says we. Like everyone. They all say we. So there is no like the Rust, overlords. It's everyone is we. So as soon as somebody starts using Rust, like and has written 3 lines of Rust, it's in Rust we. It's so strange. But it's cool. It's really cool. I'm this outsider in that I still say like I and you and they.
Mm-hmm. Right. Well, anyway, I think that's it. I think that sums up why I think TypeScript is good. And so that's my spiel. I like TypeScript. I think it's good. I think that people should use it, and people that aren't using it, that's okay. It's okay to not like TypeScript and not use TypeScript. But I do like it.
So I think that it's the reason that we have it is because JavaScript has just been weird. JavaScript's been weird in that it's been a language that doesn't have any true ownership. It's run by a committee with like people change in and out, and they have various different opinions. So, things have gone back and forth over the years with the changing of the heads. But they're not really the heads because the browser maker is the one that actually implement it. It's so strange that it's so disconnected and discombobulated. Like Node is on its own island, the W3C is on its own island, TC39 is on its own island, Chrome is on its own island, Safari is on its own island. Everything's on an island, and they're just tied very, very loosely together by this spec. And nobody can introduce a new language into the browser space because. Well, then you have to get a bunch of competitors to agree, like, yes, we want this new language, which just isn't going to happen. So like Dart, sorry, it failed. Like, okay, now there's some sort of Dart platform on Android. That's cool, I guess. But
right.
Like Dart did not succeed, isn't going to succeed, whatever. And I think TypeScript kind of hits the sweet spot between it's a different language. It offers different values, but it's close enough. Like it's got enough of JavaScript in it that it's familiar enough that people can kind of agree, like, okay, I'm not abandoning JavaScript if I use this. I'm still kind of using JavaScript.
Yeah, and that's an interesting thing because when I write TypeScript, I don't really feel like I'm in a truly different language, right? I feel like in many cases when you do jQuery or when you add in Lodash and you use it so frequently that it is, just in there everywhere, right? You don't feel like you're not using JavaScript so much as you're using this like kind of superpowered as a to put a positive connotation on the term, but this like enhanced version of the same thing. But I don't feel like I'm not using JavaScript. So the other thing I like about it is I don't feel like I'm not learning JavaScript. To conversely point that out, like if you use jQuery, you're not learning the DOM. And way back in 2008 or 2009, I didn't care that I wasn't learning the DOM. Today, I feel like I wish that I knew the DOM API better because being able to just work with the raw DOM API is valuable.
Just read the API docs for jQuery and then just type that in on window.document.
And
works the same.
Works the same. Totally works the same. Yeah.
Well, pretty much. I mean, like the jQuery documentation is more or less as verbatim as it can be what they modeled the spec after.
Mm-hmm.
So
right.
That is like a huge, in my opinion, that's a huge win for the DOM and jQuery that they defined it so well and got such great adoption.
Right.
In most cases, of course, there's always going to be those corner cases where somebody's going to be like, I'm going to go do this stupid instead. For the most part, they took the good parts of jQuery that everybody knew and understood, and they ported them directly over to the DOM the way that it ought to have been from the first place.
Right. Right. So, that is one thing I like about TypeScript. It doesn't feel like I'm not using JavaScript the way that, say, CoffeeScript did.
Yeah. So, and that's something I think is really, really valuable. You bring that up. If you're writing or TypeScript, you are learning JavaScript because you have access to all of the native APIs.
Right. And the things that it adds tends not to be like a different version of what JavaScript actually already has. Like they don't have a different for each loop on the array, right? They don't do anything like that. Everything that they add is things that don't exist in JavaScript, like types. And I think that they've done a pretty decent job with the TypeScript language.
I mean, to me, it seems like one of the things that they've done is they've built JSDoc into a language spec, more or less. Mm-hmm. And then they restrict, kind of like JavaScript, the good parts. JavaScript, the good parts is about, there's a bunch of language features, but you choose not to use them. And TypeScript is saying, well, there's a lot of stuff you can do dynamically, but we're choosing not to.
Right.
And I respect that, actually.
All right. Well, are we done? Summed up? We're ready to end? Go to picks?
Let me think on that for a moment.
We said everything we want to say. We made final points about whether we feel like TypeScript is good or bad.
I don't like it, and I hope that people will become better at JavaScript itself. But I don't know, TypeScript might be a path to do that. So, sure. Done.
This episode is sponsored by Linode. Linode is offering listeners of this podcast a $20 credit, which is good for 4 free months at their lowest plan. Their plans start at 1 gigabyte of RAM for $5 a month. You can get your servers in any of their 10 data centers, and their high memory plans start at 16 gigabytes. Get a server running in under a minute. They do hourly billing with a monthly cap on all plans, and add-on services like backups, node balancers, Longview, etc. VMs for full control, running Docker containers, encrypted disks, VPNs, etc. You can run a private Git server. They provide native SSD storage, 40 gigabit network, and Intel E5 processors. They have 24/7 friendly support, even on holidays, and a 7-day money-back guaranteed. So go check them out at linode.com/JavaScript Jabber.
All right. Who's going to do picks first?
Oh, man, I had some good ones, but I don't remember what they are. I got to take a second to...
Shall I go through mine then?
Yeah, if you got yours handy, do it.
All right. There's like gazillions of things I could pick because I just had did NGConf last week, so I had a whole week of doing stuff. Should pick Cypress. I gave a full day workshop on Cypress and a 1-hour shortened workshop on Cypress at NGConf and had a lot of fun doing those. I think Cypress is a pretty cool tool, but The one thing I think I really do want to mention from ngconf is the StackBlitz people got this guy, founder, one of the two founders of StackBlitz, Eric Simons, gave a talk at ngconf about using StackBlitz as sort of like an IDE, and he talked a lot about StackBlitz itself, but then he did something amazingly cool, which was so serendipitous because the theme at ngconf this year was space. StackBlitz is launching a membership program, and to launch a membership program, they've actually found a rocket company that shoots satellites into space, and they are launching a web server into space on somebody's satellite. It's a web server they own and have purchased, and they're launching this web server into space, which is just absolutely nuts. Like, I'm not making this up. They're literally going to send a web server into space, and so you can go to StackBlitz and you can create StackBlitz projects and actually deploy those into space if you have one of their, that's one of the, the benefits of their new membership program that you can get.
Okay, so I was looking at one of my picks and I missed some of what you said there. Did you just say you can deploy code into space just for the sake of deploying into space?
Absolutely. There's zero, in fact, there's only drawbacks because the latency to getting up to space and back is not like amazing, right?
You just run some code that's like, hi, hello from space. Hello, universe.
Right. We actually, so at Thinkster, we put together a little like what's new in NG and Angular 8 document. It's pretty short. And we built it in StackBlitz, which is completely overkill because this is like just some HTML and CSS, but StackBlitz is a whole thing. But that's how you deploy stuff into space using their thing. So it's absolutely all just for the fun and the coolness of it to say, I've got some code that literally lives in space, that is running in space. And, it's not launched yet, but go check out the talk from ngconf Eric Simons gave. I think the talk is, let me find the talk title. It's called, What If Your Dev Environment Was a PWA? And we'll put a link in the show notes. So go check that out. If you want to look also at what's new in Angular 8, then you can head to ng8-thinkster.deploy2.space. That's their domain name that everything goes out to, is deploy2.space. Which is a really fantastic domain name to have been able to snag. So yeah, that I thought was pretty fun, and watching the talk was really fun, and him talking about deploying to space, and he trolls people using some pretty cool features of StackBlitz as well. So yeah, I think that'll be, I wanted to throw in one more pick. Since there's only two of us, I'll be indulgent here. On May the 4th, Lego Star Wars came out with a new Lego set, the Tantive 4, which was the original ship that the Rebels were in at the very beginning of Episode 4, the original Star Wars movie. The Princess Leia was on, and C-3PO and R2-D2 were on. That was the Tantive 4, and they've got a new Lego set of that ship that they just barely came out with, and it's really cool. I think it's $100 or $200, so it's a pretty decent sized set. But I haven't bought it yet, but I want to, so I'll pick that as well. Very cool Lego set, and those are my picks.
Well, that sounds pretty awesome.
Yeah.
Okay. The first thing I'm going to pick is a book that's called Measure What Matters. It talks about the OKR system, which is objectives and key results. So it's a style of goal setting for, well, anything. I mean, a business, a person, an organization, whatever. But basically like setting a long-term objective and then defining key results by which if you have met the if you've created the key results, then you will have met the objective. Like it's mutually inclusive in such a way that if you meet the key results, the objective is accomplished by definition, and vice versa. If you did not meet the key results, then it's most likely that the objective was not accomplished. So it's being very specific to what key results that you're targeting are. And this is, though it goes by different names, in Google it's called OKR, in other companies it's called other things. I think that the basic idea started out of some people that worked at Intel. And the idea is also that you don't let your focus on key results get in the way of meeting your objective. So you don't lose the forest for the trees and say, well, we set this deadline for May 1st, therefore we need to do this by May 1st, and we were targeting to do it with this customer, therefore we're going to do it with this customer. The the part of the value system is that you reevaluate and say, okay, is May 1st still reasonable? Is this in the green or is this in the red? If it's in the red, then we need to scrap it and just, think about something different instead. If it's in the yellow, we need to figure out how to get it in the green, or just, that we want to push it in the red and be done with it, because you want to have good results and whatnot. And so it's just constantly reevaluating, reassessing, reassigning. So I like that book, Measure What Matters, and I would highly recommend it to other people that are trying to find improvement in any part of their life, as well as anybody who's so sick of the buzzword agile. If you just feel like if you hear agile one more time, your ears are going to bleed, OKRs might be a good book to bring up with your, or Measure What Matters might be a good conversation to bring up with your manager or whoever else, because I think whereas agile has become a meaningless buzzword that's basically like smaller waterfalls with top-down decision-making, the OKR process, I think, is more well-defined by the people that actually defined it. Whereas the agile process is something where everybody started writing a book on it, and the people that actually defined it, what they intended it for and what they meant, we have no idea, because no one's reading their books. We've got their webpage and all of these other things that are very loose interpretations of it that don't really seem to match up a lot of time. So anyway, that's that. And then another thing I'm just going to let people know, I mentioned this before, but I've started publishing some stuff on NPM under the @root organization. And it's mostly crypto stuff that's going up there right now. There's also an alternative to request, but it's zero dependency. It's in 500 lines of code, and it does 95% of what everyone uses request for, and in an exactly API identical way, such that it would pass the same tests and whatnot. But if you're into very small libraries that are zero dependency that get the job done, I'd be interested in having more collaboration and more people bringing stuff to that if you want to. If not, if that sounds something interesting, especially the crypto stuff, because the crypto space historically has been just terrible, and it's really gotten so much better both in Node and the browser. So for the browser, I'm actually publishing stuff to @BlueCrypt. So anyway, if you're in that and you want to check that out and give me feedback, awesome. If not, then oh well, I just wasted 30 seconds of my breath or more. But that's something that I'm happy doing it. It's it's feeling fun and exciting to me, and so I thought I'd share.
Cool. All right. Well, thanks again, everybody, for listening, and we will be back again next week.
Adios.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.